Welcome to the CuScribe CNC milling tutorial. In this video, we will show you how to machine parts using the CuScribe. We will be using Fusion 360 to generate G-code for our part, then we will use the CuScribe control panel to send the file to our CuScribe. Visit the Getting Started section of our website for software installation instructions. The first step is to model our part in Fusion 360 or import a step file of your part if you model it using another CAD program. Next, we define the stock material that we will be cutting the part out of. For this tutorial, we are using a plastic plate with the same outer dimensions as our part. After switching from the model area to the cam area of Fusion 360, we select Setup and New Setup. In the Stock tab, we set the offsets to 0 since the stock is the same size as our model. Next, in the Setup tab, we define the origin and axes for our coordinate system. It's important that the coordinate system is set up as shown. This corresponds to the CuScribe's coordinate system. Now we can define our cut paths. We will start by creating pocket cuts for our two slots. A pocket cut will remove all material from the defined area. We select 2D and 2D pocket, then click on our two geometries for the slots, and select the 1/8 inch flat end mill tool. Because we will be setting the spindle speed manually on the CuScribe, we do not need to worry about the spindle related settings in the feed and speed section. Recommended feeds and speeds for our tools and materials are available in our Getting Started section at CuScribe.com. We will set our cutting feed rate as recommended and set the lead in, lead out, ramp, and plunge settings to the recommended plunge speed. In the Heights tab, we set the clearance, retract, and feed height to 1 mm. This ensures the tool is 1 mm above the stock material when moving around. The top of our cut we set to start at the top of our stock, and the bottom we want to be at the bottom of the slot as shown in the model. Our cutting bit will need to make several passes to cut out all the material we want removed. For this reason, we will set the max roughing step and finishing step down to the recommended setting from the CuScribe Feeds and Speeds webpage. In the final tab, we will set the safe distance to 0.5 mm, meaning it's safe to generate tool paths within 0.5 mm of the workpiece. After hitting OK, we see the cut paths generated for our slots. Next, we will be creating the cut paths for our holes. We select 2D and 2D contour this time. Contour milling is used to cut the outline of a custom shape. Once again, we select the 1/8 inch flat end mill and input the same recommended settings. Then, in the geometry section, we select our holes. We set our heights as we did before, only this time we want to cut all the way through our material. So we set the bottom cut height to the bottom of our stock. We add a -1 mm offset to make sure that the drill bit cuts all the way through the material. We also set our max cut depths per pass, as we did before, and update our safe distance. For this operation, we will uncheck the lead in and lead out features. These features are used to generate optimized cut paths where the tool lowers and translates sideways simultaneously. Because the holes we are machining are small, we would not have enough room to generate these kinds of paths for these operations. We hit OK and see the cut paths generated for our holes. Making sure to select the main setup from the tree view on the left, we can then click Actions and Post-Process. Failure to select the main setup might result in only exporting some of the cut paths. We select TinyG as our post-processor and click Post. Although the CuScribe uses the Gerbil firmware, we have found the TinyG post-processor to be more reliable. We have now exported our desired G-code and are ready to set up our CuScribe. After plugging in the USB cable to our computer and to the CuScribe, we plug in our power cable and set the CuScribe switch to the off position. This will allow us to manually slide the X and Y axes during the setup process. We now lift the swing arm, mount our 1/8 inch cutting tool, and set the dust collector to the utmost position. Using double-sided mounting tape, we stick our material to the spoil board. To avoid getting the adhesive on the cutting tool, we place the tape in areas where we will not be milling through the entire board. We then stick the stock onto the spoil board. Offsetting it from the alignment bracket is done to ensure we don't accidentally cut into the bracket. Now we lower the swing arm and manually slide the X and Y axes to align the center of our cutting bit with the bottom left corner of our stock. After powering on the CuScribe, we connect to it using the CuScribe control panel. We click Clear Alarms to enable movement of the CuScribe. Then, using a small step size, we use the Z jog buttons to place the cutting bit just above the workpiece. We use a piece of paper to ensure it's not touching. With the bit perfectly located at our stock's origin, we hit the Reset 0 button. The CuScribe now understands this to be our starting point. We load our G-code file and hit Print. An alert pops up telling us to turn on the spindle and vacuum before continuing. After doing so, we hit the Yes button and our cut begins. With our piece machined, we are now ready to assemble our creation. We hope you have enjoyed this tutorial. For more advanced CNC milling features, check out the Fusion 360 website.